Hi, Carolyn. I wanted to do this video real quick to show you the linear regression problem that you were asking me about. So I think I'm showing you the problem right now. So let me go ahead and switch over to the calculator so we can actually work it out. Okay, so it's a regression problem. So we need to put that data set into our calculator. That's all going to start with our stats button. So we'll hit stats. You said you've kind of done this a couple of times, so I think you know where these features are, but whenever you're going to put information in, we're going to stay on this first column because we need to edit. Now, my calculator has something in from a different problem, so anytime you need to clear out an old list, you highlight the top there where it says the name of the list and then hit clear and then enter to actually run the command. Do the same thing on my first one. Go up there and highlight the name, then hit clear, followed by enter. Okay, so now the X values, the first values were just y2s, 1, 3, 5, 7, 9. So I will just type those in. You can hit enter. I think you can also just hit down and it will do that. Okay, and then I'm going to type in the Y values, 7, 10, 13, and so on. Get those typed in. Seven, 10, 13, 16, 19. Okay, so there's our data. Make sure that they end at the same level. If you have one column of values that has more entries in it than the other, then at some point it can't pair two numbers together and gives you an error message. All right, so we have that. Let's go back to our main screen now. I don't want to do anything else from inside that editing screen. So now that we have the data loaded in, we just want the calculator to help us to quickly find the equation of the line that would fit through that group of points the best. So I'm going to go here back into stats, and then I'm going to go over to calculate because that's where we do stuff with the data we just typed in. And so the first three are a different kind of statistical analysis, but once we get to numbers 4 through, I don't know, the 10th or 11th one, we're doing different kinds of regression modeling. And right now for this class, our first module just deals with linear regression. So we're going to select this time number 4. Throughout the course, we will make different choices at this stage, but right now it's said to find the equation of a line. So that's a linear regression. So I'm going to select that. And it wants us to, it's reminding us here that the X there is corresponding to the entries we have in list 1. Y goes with list 2. So I'm going to just scooch down here to calculate and hit enter, and it will give us the slope number and the y-intercept number. Now, if you look at that, do you see it doesn't put the equation together for you, but it shows you how to assemble it. So lines look like slope times x plus b, mx plus b. Calculators just always call the first coefficient a, second one b, and so on. So our linear function that we would type into MyMathLab for the answer, you just had to put the boxes, these numbers in the boxes, and it constructed the rest of the equation for you. So the homework just says y equals blank box times x plus another blank box. So we're just going to type both of those values in. So it has a slope of 1.5 and the b value is 5.5. Okay, so if we go back, which I don't know if I need to be able to do this on, I can do this on your homework problem, but let's see. So it says 1.5 was the slope and 5.5 was the b value or the y-intercept number. So let's check that. Okay, so that's how we do it. The x values go in list 1, y values go in list 2. We go back to the main screen once we've edited and put that information in, and then we do stat, right arrow over to calc for calculations, and we go down to the 4th one that says linear regression. Once we have that showing on the screen, we scroll down to calculate, and it will give us these values that we need. So that's pretty much it. If you're wondering like what it is that we just did, let me show you here. If I wanted to see how those particular points looked, if I graphed them against X and Y, you don't have to worry about how to do all this right now. I'm just showing you. That's what it would look like if my X values are 1, 3, 5, 7, 9, and the Y values are 7, 10, 13, 16, 19. So there's the points. If I were to put that line in that we just figured out, 1.5 x plus 5.5, this line should fit right through those points. So there's the line, the slope of 1.5, y-intercept 5.5. If I hit the graph, see how it hits all those points? It means this particular data set was exactly collinear. All of the points actually are shared on that same line. If we want to know what that line is, I mean, we can get out a pencil and paper and do the point slope form and all of that stuff between 2 points on the line. But regression is better because if your points don't all sit on the same line, the regression technique takes information from all of the points and kind of does a bit of averaging and then comes up with the best slope and the best y-intercept for the line that fits closest, if not exactly, through all the points. Okay, so that is how we do linear regression, or that's at least how we do that particular problem in the homework. Hope that helps.